Hello. So today we're going to be talking about a method for solving quadratic equations called the mean product method. Now, the mean product method is actually not that different from other methods of solving quadratic equations that you might have heard of, such as completing the square or the quadratic formula. However, the advantage of the mean product method is that it has a visual element, which I'll talk about in a little bit, that allows us to remember and visualize the steps involved in solving quadratic equations. And it also allows us to use all of our knowledge that we have about quadratic equations and parabolas in general to solve quadratic equations. So let's turn to an example here. We're going to be solving this equation. Now, at first glance, it may not look like a quadratic equation, but if you look at it carefully, you'll see that because we have 2x multiplied by x plus 1, it actually is a quadratic equation, because at some point you're going to get an x squared, and that's going to be the highest, 2 is going to be the highest power of the variable x. So our first step is to get this in a form that we can use for this method. And the method that we want is, we want to write the equation in this form: x squared plus bx plus c equals 0. Now, you'll notice that this is not quite the standard form of quadratic equations that you may have heard of. The standard form for quadratic equations is ax squared plus bx plus c equals 0. And you'll notice here that for the mean product method, we want the leading coefficient, in other words, the coefficient of x squared, to be 1. So if we have a number in front of the 1, we're going to divide by that number throughout the entire equation to get the equation in the form that we want. So here, what we want to do is we want to multiply this expression on the left side out. We're going to get 2x squared plus 2x, and then that equals 7. Now, it's not quite in the form that we want, x squared plus bx plus c equals 0. So we're going to subtract 7 on both sides to get the equation equal to 0. And that gives us 2x squared plus 2x minus 7. Now, this is standard form, but to use the mean product method, we need to get the leading coefficient to be 1. So we're going to divide everything by 2. And so what we'll get here is x squared plus x minus 7 over 2 equals 0. Now, you'll notice that we have a fraction in this equation. That's okay. Even if we get fractions using this method, I recommend that you use a calculator to help you calculate anything that we do here that involves fractions. Now, we use an important property of quadratic equations, namely that if we have an equation in the form x squared plus bx plus c, we know that the sum of the roots would be negative b, and the product of the roots would equal c. So in this case, because we've written the equation in this form x squared plus x minus 7 over 2 equals 0, we can determine here that the product of the roots is negative 7 over 2. And we see here that the sum of the roots is the coefficient of x, which is 1, but we're going to take the opposite of that, so that's going to be negative 1. Now, if you use this method, I strongly recommend that you show all of the work that I'm doing here so that you can clearly communicate your work to people who are not familiar with this method. So please don't skip this step. So we know that the sum of the roots is negative 1, and we know that the product of the roots is negative 7 over 2. We can now draw a graph, a sketch of this parabola. Now, this sketch is really important, particularly for those, if you're trying to communicate this work to people who aren't familiar with this method. We want to draw a parabola. We want to draw something that would represent the roots, in this case, x sub 1 and x sub 2, and we're going to draw a line right down the middle of the parabola that represents the axis of symmetry. Now, we can see here from this diagram that if the roots of the equation are x sub 1 and x sub 2, we can, let's say, use this, call this distance here from the axis of symmetry to one of the roots. Let's call it u. It's important, by the way, if you use this method, that you label your diagram so that people know what u represents. And let's let m represent the x value in the equation of the axis of symmetry. Now, we see here that if the sum of the roots is -1, then the mean of the roots, which is here, I can use the letter m for that, is going to be half of the sum. So the mean of the roots is x sub 1 plus x sub 2 over 2. And I'll write this on the side. You don't need to write this in your work, but this may be helpful for you to understand that the mean of the roots is x sub 1 plus x sub 2 divided by 2. That's the average. We know that the sum of the roots is -b. So this turns out to be that the mean of the roots is going to be -b over 2. So we found our sum of the roots, which is -1. And so we're just going to take -1 and divide it by 2. And so that's the equation of the axis of symmetry, x equals -1/2. Now, the distance from the axis of symmetry to one of the roots is u. We don't know that. We do, however, know, based on this diagram, that x sub 1 is going to be the mean, which is m minus u. X sub 2 is going to be m plus u. And so that's going to be -1/2 minus u. And then x sub 2, the second root, is going to be -1/2 plus u. Now, here's the really interesting part. The product of the roots, in other words, x sub 1 times x sub 2, that's equal to c. Well, x sub 1, we just said, was -1/2 minus u, and x sub 2 is -1/2 plus u, and that equals c, which, as we said over here, was -7 over 2, because that's the product of the roots right here. Now, we can use a box to multiply this. As you get more comfortable with this method, you may skip this part with the box, because you'll see that this always works out to be a difference of 2 squares. So this is +1/4 plus 1/2 u minus 1/2 u minus u squared equals -7 over 2. Now, you'll notice that when we multiply, when we add these terms together, you're going to get 1/4. The middle terms, 1/2 u and -1/2 u, will always add up to 0. And so you get 1/4 minus u squared equals -7 over 2. We're going to add 7 over 2. And we're going to add u squared. Our goal here is to get u squared to the right side of the equation. We're going to move the numbers over to the left side. So these 7 over 2s add up to 0. These u squares add up to 0. We're going to get 1/4 plus 7 over 2. Now, 1/4 plus 7 over 2 may be tricky for you. You can use a calculator, enter these fractions into the calculator, convert your answer, if it's a decimal, into a fraction, and you will get 15 over 4 equals u squared. And so now we can solve for u. U is equal to, now, because we're concerned with the distance from the axis of symmetry to one of the roots, it doesn't really matter whether we look at the, it doesn't really matter whether u is positive or negative. We really are only concerned about the distance. So we're just going to ignore any negative root that we get from this equation, u squared equals 15 over 2. So we can just say that u is equal to the square root of 15 over 4 if we take the square root of both sides of this. Now, we use the division property of radicals. This will give us square root of 15 over the square root of 4. The square root of 15 can't be simplified. Square root of 4 is 2. And so we get u equals the square root of 15 over 2. And now we're almost done, because we said over here that x sub 1 is negative a half minus u. We just found u, and that's going to be minus square root of 15 over 2. And x sub 2 is going to be negative a half plus the square root of 15 over 2, because that's u. And so that, in fact, is our answer right here. We could also write this as negative 1/2 plus or minus square root of 15 over 2. You may also see this written as one fraction, because we do have the same denominator in both fractions. And so we could write negative 1 plus or minus square root of 15 over 2. So that's how we use the mean product method to solve a quadratic equation, which in this case has irrational roots.